Anyway, so this is not Lars's talk. He is in room 5. I have been moved here. Didn't get the memo, so I was over in Lars's room 5 minutes ago, and he's like, didn't you get the email? You're in room 2. Okay, so made it on time. All is good. This is the Blazor server-side deep dive. And I know it says Carl Franklin's Blazor Cookbook up there, but what I've done is I don't have any slides. I have a document, an HTML document with some code snippets and directions and links and images, and I'll be giving that to you guys so you can do exactly what I'm doing here when you leave here today. I got on the Blazor bandwagon pretty early on the server side anyway. The WebAssembly thing I've been taking a closer look at lately, but I've been messing around with the server-side stuff since the last summer. I was so enamored of it that I went and redid all the podcast back-end web stuff that I had written previously in vanilla JavaScript and HTML and Web API. But I redid the front end in like a man week. I was like, I have never felt so productive in my life with a front-end web technology, not even web forms. This is just blowing it out of the water for me. So I'm going to show you, we're going to build an application. You know, it's not going to do a whole lot, but it's going to exercise all of the things that I've learned over the past months. And we'll be going down into the system and take a look at what's really going on under the hood, which is what I think you're really, really interested in. So this, as I said, is a cookbook. This is from my, my online workshop that I have been doing, and just a little part of it. It's a full-day workshop, and the link is here. So what I'm going to do is just follow the instructions. And I'm going to create a new project in Visual Studio 2019, and it'll be a Blazor app called Band Booker. So the whole idea here for this big application is that, so this is going to allow us to define instruments like piano, guitar, drums, then musicians that play those instruments, and then bands that have those musicians in them, and the venues where the bands play, and then bookings, which links all of those things together, links, you know, a band and a venue and a date, and the particular musicians of that band, they're going to play that gig. And the whole idea came out because I am in a band, and trying to get everybody in the band together, it's a 10-piece band, trying to get everybody together to accept or reject a gig that comes along in a timely manner by email is just a big pain. It just doesn't work. And so, you know, when my brother asks, hey, is, you know, such and such playing this gig? I'm like, oh, I don't know. Now I have to go search through Google, Gmail, and find, you know, where they said yay or nay. It was just a big problem. So I figured this was a nice little exercise to go through this, building this app. So that's what we're going to do. Called Band Booker. And, you know, like all Blazor, server-side Blazor apps, oh, that's awesome. All right, cool. So let me do this again. I don't know why that happened, but let me do this again. It might be that there's already a project in that directory. I don't know why it was in the dev intersection directory. Okay, so this is going to be your standard demo first, as long as this runs. All right, so let's find a good place for it. Here we go. Band Booker. Blazor server app. This is the latest and greatest. Visual Studio. I'll be talking about the differences between client-side and server-side as well. But first, I want to just show you the quintessential Blazor demo, which is the counter, where you press a button and it updates a counter. And we'll just take a look at what's going on under the hood here. So you can see I'm updating this counter. I got this click me button, and every time I click, it increments. All right, simple event handling. So let's take a look and see what's going on under the hood. Yeah, this is the code right here for the counter page, which I will pull up here. So let's look at this. What's going on here is we've got just an HTML button, right? And rather than an on-click without an @ sign, we have an @onClick. That @ sign basically is a Blazor directive that's saying, hey, this is going to run code on the server, and Blazor's got to handle this, rather than JavaScript. If we left out the @ it would be just a JavaScript on-click. So then you have this @code block. It doesn't have to be in the Razor page itself. You can do code behind, and I'll show you how to do that. But there it is. You have a current count. You have an increment count, which increments that number. And we're just displaying that in HTML. And there's the current count. So no doubt you guys have seen this before. Not too interesting. But let's talk about the difference between client-side Blazor and server-side Blazor. If this was client-side Blazor, that code would be running in the browser, right? And it would be compiled to WebAssembly bytecode, essentially. It's not really compiled, it's sort of interpreted, but you get the idea. The code is actually C# running in the browser. Here, we're on the server, okay? So how does that happen? Well, the magic of that is SignalR. And SignalR is a WebSockets framework, right? It uses WebSockets, but it can also use other means of doing what sockets do. And if you've ever done any sockets programming, sockets are the underlying architecture, the transport. You're the way that all internet programming applications that use the internet, like browsers and email clients, that's how they access TCP/IP. Is through a socket. And when a browser makes a request to a website, it opens a socket connection, and then it sends a request, it gets a response, and then that connection is closed by the server. Whereas with SignalR, we're using a WebSocket that is connected, and it stays connected, and it stays open. And as long as that socket is open, the client can send data to the server, server can send data back to the client. It's a two-way persistent connection. So this all happens magically for you under the hood. So rather than when you click that button, rather than making an HTTP request to a server and getting some JSON back, and then with JavaScript sort of changing the DOM yourself, what happens is it goes over that SignalR connection, and the server is keeping a graph in memory of the DOM of the browser for every client. So it knows the state of the DOM in the browser, executes the code, and then does a diff in that graph on the server to find out what has changed UI-wise in the browser. And then it sends back over that same SignalR connection all of the information that Blazor needs to update the UI in the DOM, okay? So all of this happens very quickly and very, actually, inexpensively in terms of performance and in terms of data that's actually traveling back and forth. It's actually very efficient. So that's the big difference between server-side Blazor and client-side Blazor, and there's just a couple of things to consider here. The hosting model of the server has a few benefits, and I've already outlined them, but download size significantly smaller. The startup size, basically when you run it, you don't have to ship down the Blazor runtime, which is about 4 megabytes now, but they're looking to get that under 2 megabytes. so the app loads faster. Since everything's running on the server, you can take advantage of all of that the server has to offer code-wise, including the architecture, right? So you can access your data stores and all of that stuff without having to, without being required to use a web API or some other REST interface to get data, because you're already on the server. So there's that advantage. And then, of course, it works on just about every browser, and even ones that don't support WebAssembly. So the downsides are that there may be latency issues because you are making a network hop for every interaction. No offline support. So if your users aren't connected to the internet or the internet connection goes down, the application will cease to function. And scalability has its own challenges with SignalR, but we'll talk about that. Also, an ASP.NET Core server is required, not necessarily a big deal these days. This is a slide that I stole from Ryan Nowak, who works on the ASP.NET Core team, and was, according to him, the second person to ever work on the Blazor project. So just by comparison, let's talk about bandwidth and how much bandwidth these things consume. Streaming video is perhaps the worst. At 4K, we're talking a lot. What is that? 53 megabytes. I don't know what that is. With 53,000 kilobytes, that's 53 megabytes per second. 1,000 kilobytes per second for 320p. And streaming audio is about 160 kbps. But Blazor server, one operation takes about 0.5 kbps. So it really is pretty efficient. And if you want to take a look at the SignalR traffic, I wrote a blog post here on AppVNext where I show you how to log the SignalR traffic that's going back and forth over the wire. And we actually can look at some of it as it's being logged. And there's not a whole lot. But it is interesting nonetheless if you're into that, figuring out what's going over the wire. All right. So the difference between Blazor, server-side Blazor, and your traditional ASP.NET Core Razor application, MVC application, it is completely different, right? So when a Razor page or view is rendered, every line of that Razor code emits HTML in text form, and then the server disposes of that page or view instance, including any state that was produced. And another request for the page occurs, for instance, when validation fails, the entire page is re-rendered to HTML again, and the page is sent to the client. So there's a lot more traffic going back and forth with an MVC application than with a Blazor server application. We're basically talking about a spa where you don't have to do any of the goo of accessing data in your web API and updating the client. So that's the magic of Blazor server. So let's talk about scaling. Microsoft did some tests, and it turns out that just without any of your code or your state or your data, every connected client requires about 85K of overhead. And this is a screenshot from Dan Roth's video that he did at .NET Conf. They did this test for appropriate latency and with active concurrent clients. And they used two different instances of server in Azure, right? The D1 V2 standard, which is 3.5 gigs of RAM, could handle 5,000 concurrent active users. But if they upgraded that to a 14 gig server with 4 vCPUs, 20,000 plus. So also, right, we'll talk about scaling out SignalR, but the real bottleneck seems to be memory, right? So more memory means you can handle more concurrent clients. with your data. So they found in this particular test, which was a real test with real data, that we got up to like 250K of memory per client. So it's a little bit different. You got to do the math and think about that. So to conserve memory usage, you want to pay attention to how much memory is being used in your app per client, right? So the worst thing you could do is allow the client to load up, 1 million records from your database in object form, put them in a list, and then display them, right, in a select. That would be the worst, because now every instance, every concurrent client connection is taking up all of that memory. So a better idea is to use things like, search boxes to not allow more than so many records to be displayed on the page at once. But, this should be standard procedure for you now anyways as web developers. You probably already know that, but you really have to pay attention to it in Blazor. So in addition to memory, available WebSockets can also be depleted if the number of concurrent clients exceeds the number of available SignalR connections. So to scale that, you might consider using the Azure SignalR service, completely offloading the SignalR service to Azure. So here's a link to an article that explains how to make that happen. And you can read this on your own time, but this basically shows you how to provision a SignalR service in Azure and how to use the secret sauce in configuration to set your Azure connection string, and then you can see it just works. Now we're talking about the SignalR service that Blazor uses internally. That's what we're replacing with Azure SignalR. So that's always a good idea if you're planning on making a really big app. All right, so let's talk about state. Let's go back to our app here. Back to our old trusty counter. And you can see that this is working. If I go to another page, like here's the home page, and then go back to the counter, oh, what happened? It's at 0 again. So all of the state goes away when you navigate to another page in server-side Blazor. That's what happens. So you may not want that. And it may be perfectly okay, but you may not want that behavior. You may want them to go to all the pages and keep the state no matter what page they go to. So to ameliorate this, we're going to create a service and offload all the state into the service, which will live one per client across all of the pages. And then we'll just inject that service and use it wherever we want. So we'll make a class, we'll add a class here called AppState. And it's a very simple class. Just has a clicks property. All right. And now we're going to go to the services, startup CS in the services, and we're going to add scoped for AppState. And so this is how we're going to be able to use this from wherever we are. And you can see there's already add singleton for the weather forecast service. That's another demo. I'll show you this one. The weather forecast service is just simply a class that retrieves data, and every time you go there, you'll see a different random set of weather forecast data, okay? But look at the difference. That weather forecast service is a singleton, whereas we're adding AppState as scoped. So the difference there is a singleton has one instance that's shared across all users. All users, all clients get the same instance of that object. Whereas if you do add scoped, now it's per client, right? So every client gets a copy of this app state, and wherever you inject it, you're accessing that same instance for that client, okay? There's another one, transient, add transient, and that, of course, there is no state. That is just a per page life cycle. So that would work exactly, if we used it, it would work exactly as the counter works right now. All right, so let's update our counter.razor to use this service. And so you can see I'm using the @inject directive right here. Here's the type, AppState, and here's our variable, AppState. The current count is now @appstate.clicks. Increment count is still being called, but now instead of having a local variable, we're using that AppState and incrementing that. And now I can increment it, no problem. I switch to home, I come back, ta-dam. Cool? So that can be really important. It's probably maybe one of the first things that you would do in a real application. So yeah, just talking about these things. All right, so let's talk about how server-side Blazor handles unhandled exceptions. Let's just create an exception here. Throw a new exception, ouch. All right, so it'll break in Visual Studio, but let's just go and continue so we can see more of like what would happen in the real world. And you can see here, an unhandled exception has occurred. See the browser dev tools for details, but guess what? The app stops working. The connection has been severed. And take a look at this if we go to the browser tools. Right? Connection disconnected right there. So here's the exception, ouch, right? That's good. But this is the most important thing to know. And this is by design, that the SignalR connection has been completely severed. But it's by design because your code is now in a state that is dangerous, right? It could be used as an attack vector. Unhandled exception has occurred. That may have occurred, somewhere where, somebody's entering a credit card or putting an order through, right? We don't know what the state of that is. Why would we allow the user to continue to use the application? It just opens up all sorts of possibilities for security threats. So that's by design. All right, so now let's get into the real application here. We're going to add a couple of classes, instrument and musician. And I'll create a models folder first. And add to that instrument. And now another one, musician. All right, so instrument basically has an ID and a name. Musician has an ID and a name and a list of instruments. Couldn't be simpler. So let's do some UI for starting the UI to show a list of instruments, and then we'll get a little bit more into it. So I'm going to go to index.razor, which is your first landing page. We're just going to modify that. First of all, here's the markup with a select. But let's go down to the code first. I have a list of instruments. And there's a few overrides that you can do for lifecycle management. One of them is onInitialized. It can be async if you want it to be async. This is obviously, when everything's ready to roll. But there's a few other ones. One of them is onParametersSet, which you can pass parameters to pages, all right? And those parameters are not set at onInitialized, so they won't exist yet. But anyway, we're going to create a new list of instruments, and we're going to just set some of these values in here: guitar, keyboards, bass, and drums. Up here in the select, right, we have this @for each, var instrument and instruments, and we're going to put an option in the select for each one of those, set the value to the ID, and the text to the name. And no JavaScript. Pretty cool, huh? All right. Let's continue. So we're going to add a few buttons for new, edit, and delete right below this select. And we need these methods now: new instrument button click, edit instrument button click, and delete button click. We'll just create those empty for now, so it will actually run. Again, not doing too much here, not at all. All right, so let's continue. And these are, you can see these don't have any particular signature. They're just void. All right. So now we're going to add a Boolean disable instrument edit button, because the initial state of this, we should not allow a user to click edit or delete until one of the items has been selected. Doesn't make any sense. So that's how it will look right up front. Yeah, and now we have to modify the edit and delete buttons so that with the disabled attribute, so they can pay attention to that. Right, so disabled equals @disable instrument edit button. So now these guys are in their proper state for, Now we have to do the rest of it, which is when one item is selected, we will enable those buttons. So we have to have a selected instrument. Let's do that. So we have a selected instrument and an instrument selected method. Now this one we're going to link in the UI, in the select, but you notice that there's a change event args here. And so the args value to string is going to be passed this value right there, which is the ID. So now all I'm going to do is do a little link and say the selected instrument is from X and instrument where the ID matches, and pull out the first one, and then disable or enable the buttons accordingly. So we have to modify the select. So that now onChange calls instrument selected. That's the only change right there. Boom. Our buttons still don't do anything, but now at least the enable-disable behavior works. All right, so before we go any further, let me show you how to do the code behind thing. So of course, if you're looking at this, there's a couple of weird things. First of all, there's some strange Visual Studio highlighting here that is just drives me nuts a little bit. I'm not sure why that is, but also some things don't work, like if I have a variable here and I hit, control period to pull up refactorings, nothing happens. So this is a blatant sign that you are not in the real Visual Studio code editor here. This is a sort of a modified, half-assed version of it. So in order to do code behind, it's pretty easy. You just, wherever your Razor page is, you add a class that says whatever the Razor file is, and then a .cs at the end. So index.razor.cs. And look at that. It's all nested and everything's ready to go. Now, the thing is, we can't call this index because index is already a class for that Razor page, so we actually have to rename it to something else. So I'm going to call it index code. So here's index code that has all of the same code in it, and it also derives from component base, has all the same code in it that we currently have in the code block in the index page itself, right? Our blank button handlers, our instruments, our uninitialized, everything is exactly the same. Now all we have to do is change index razor to inherit from that code and completely delete the code block. So now you can see inherits index code, everything else exactly the same. Here's our instruments, here's our button, but now we have this beautiful full Visual Studio experience of editing. Control period brings up the refactorings, all that stuff. And of course it works just like before. All right, so another change we're going to make is to show the selected instrument as selected in the list. Because now we have a selected instrument, right? So let's reflect. If it gets set, right, then we're going to use the selected attribute. Otherwise, we're not going to use it. Okay. So we're going to start with the code to delete an instrument. And that's here in the delete instrument button click. So if the selected instrument is not null, in other words, we have one that's selected, we're going to remove that from our instruments collection, And just an easy way out, if we still have instruments in the list, we're going to set the selected instrument to the first one, rather than trying to figure out, which one was before it or anything like that. I guess we could set it to last. Might be better, but you never know. You might be in the middle of the list. All right, so let's just see if that works. Oh, it's not going to work yet because we haven't wired up. Oh, yeah, we have. Yeah. That'll work. All right, so drums. Delete. There we go. Yep, that was easy. All right, so now we're going to talk about components. We're going to actually build a component that will allow us to add an instrument or edit an instrument. The only field is name, so when you see it, it's going to be very simple, but we will be able to use it as a component. And after we do that, for musician, the musician will have its own editor, but it will be using a generic component that we can reuse with different types. That's going to be cool. So we're going to add a new component called InstrumentEditor, and it's going to be a Razor component. I'll show you that it's a little bit different than what you might think. What you might think is when you right-click on pages and say Add, and it says Razor page. That's not what you want. You want a new item over in Web, a Razor component. That's going to give you a Blazor Razor component. InstrumentEditor. Okay, I'm just going to replace that with my clipboard inheritance here. So we have a Boolean show instrument panel. This is one of our methods. Our fields here, and we have these things called parameters. These are essentially public properties. Right? Parameters are how you pass data in and out from your component to your calling code. And you also notice that 3 of these are of type event callback. So those are essentially event handlers, or events that the calling code can handle. Way different than your standard C# event model, right? Easy. Actually, much easier. All right, well anyway, we have one for cancel pressed, instrument added, instrument updated. This component here isn't actually going to do any management of your instrument list or any data access or anything like that. It's purely a UI component that's going to allow you to change the name. And then it will, then it has these buttons, one for submit and one for cancel. Also, notice that the text, where is it? The text of the button, submit button text, is also something that we can change, right? Because it would either be add or update, depending on which one we're doing. And then we have public methods for a new instrument, edit instrument, and we have the handlers for the submit button pressed and the cancel button pressed. And this is how we invoke the method, invoke the event. Instrument added, invoke async. So in here we have these validation controls. And you might have noticed this, that in this div, we have, instead of an input tag, we have an input text tag. And there's also a couple things here that you may not have seen before. One is an edit form, and within that, a data annotations validator and a validation summary. So this is Blazor's validation system. And the edit form, whatever is in an edit form, that tells Blazor, okay, we're doing possible validation here. The data annotations validator says, I want you to validate against the annotations that are in the model. We don't have any yet, but we're going to add them. And we're going to say that the maximum length of that name field can be 50 characters, and that's it. So with using the input text, it's exactly like the input tag, except that it has this extra validation stuff. And you're going to use the bind value to bind that. So let's add some validation to the instrument class. That's in models, instrument. So we're going to use the system component model data annotations namespace. And we're going to add required as an attribute for name. So it can't get away with passing anything. And then we're also going to say that maximum number of characters is 50, and if they exceed that, we even have an error message here. Very cool so far. All right, so now the instrument editor code, this is what I was just talking about, this sort of the tour of the code. One thing you might notice is that I have a button type equals submit, for the submit button and button type equals button for the cancel button. If you didn't put this in here, Blazor would treat the cancel button also as a submit button. And what you do with submit is right here, on valid submit equals submit button pressed. But it's only going to happen if all the validations pass. All right, cool. So now let's go back to index razor and we'll add the markup to instantiate that component. All right. So we have an instrument error message we have to add. We're going to add code for all of these things. I guess I'll come back to this after we add that code, so we'll get rid of the squiggles. In particular, pay attention to @ref. So let me go to my code behind here. All right, so we have an instrument editor. This is the component that we just made, InstrumentEditor reference called InstrumentEditor, and in a message and all sorts of other things. Going back to index now, that @ref equals InstrumentEditor basically links our code reference to this particular instance of the component. So that's how we can grab a reference to the component and then call methods on it. These are the parameters right here. Instrument equals selected instrument. So we're passing instrument as a parameter, actually. And cancel pressed and instrument added, instrument updated, all of those things. Also need to fill in the button click handlers for new and edit instrument, which would be right here. And now we've also added a variable called disable instrument list. And you can use that to enable and disable the list of instruments while editing or adding. So that we can use to disable the list. Because we don't want to select an item and then say edit and then leave this select statement enabled, a select tag enabled so that the user can click on another one. We don't want that. Now there's another thing here my code does, which is a stupid JavaScript trick for setting focus. I don't know, maybe it'll run right now, maybe it won't. Let's just see. And I'll show you the difference between these two. All right, so I click on guitar and I edit, there it is. But notice that the text guitar, this input is not in focus. I have to actually click on it before I can do any editing. Wouldn't it be cool if it was just in focus, right? But it turns out there is no focus method you can call on these tags, right? I can't get a reference to the actual tag itself because that's in the DOM and they generally frown on that. So at this point in time, Blazor doesn't support that in the box, but you can use JavaScript interop to achieve it. And talking to Steve Sanderson, he says that's most likely coming along with some other things, right? So check this out. I'm going to add some JavaScript to the main file. Instead of having an index.html, we have an _host CS.html. And this is sort of the main page template for everything. And I'm going to add this script here. So I've got a window.setFocus method that passes an ID, an ID of an element. And instead of just calling element.focus and element.select, you'll notice that I'm doing a little trick here. Because we're going to be calling this from a button click handler, right? The element to edit won't even exist when you're in that, it won't exist yet when you're in that button handler. So you have to do some asynchronous trickery to make this work. So what I'm doing is I'm calling this private function, internal focus, with a 10 millisecond timeout. And there I get the element by ID, but right away, the first time, it's going to be null. And so then we're going to call ourselves in another 10 milliseconds with a set timeout and exit. And so this is going to keep going on until such time as, the element reference comes back not null. And then we'll set the focus and select. And yep, it's kind of a janky hack, but it works. And, let's just hope that we don't get into an infinite loop there. But that would be your fault. Right? All right, so here's how we call JavaScript. We inject this IJS runtime, and that's going to be an instrument editor, because that's where we're doing this. IJS runtime, and then we have a variable JS that we can use. And here's the code. We have to give our input text element an ID, right? Instrument.name. So let's do that. That's this guy right here. Come on, what are you doing? I guess I selected that too. All right, here we go. So ID instrument.name, because that's what we're going to pass. And now we're going to, in the new instrument and edit instrument, we're going to await JS invoke void async, void because it returns nothing. But we could also do invoke async and return a value. So we have that set focus. And that's what we're going to call. So that is new instrument and edit instrument right there. So now they've changed to have the async and return a task, which is nothing. And now when we say new instrument and edit instrument, we show the panel, we can do that set focus little trick. Boom. That would be the same in WebAssembly, Blazor as well. Nothing server-side about that. Okay. Did that actually work? Let's see. Let me go back to index. Razor CS. Okay. Let me make sure. Keyboards. Keyboard. Update. Yeah, it worked. Okay. And we can delete. So we can also add. There we go. So our basic CRUD operations are working. So now let's talk about generic components. This is really cool. The musician editor has, the name, but it also has that list of instruments, right? So I have this, another blog post that I wrote. I'll grab this code first. And this is publicly available too in this blog post, which is linked right down here. Oh man, there's a lot of code here. I'll just go to it. It's at appvnext.appvnext.com. Here's the blog post. So that is what the UI looks like, right? You have the list of all instruments on the left, the selected instruments on the right, all of the names of the instruments, and when you select one, you can add a single one, add all of them, or deselect all of them, and it moves the instruments from one side to the other. But the cool thing is this is such a reusable component because I don't want it just to be hard-coded for instruments. I want to be able to use that for, musicians in the band editor, right? What musicians are in this band? I want to be able to pick musicians. So I wanted a generic thing, and that's exactly what we have here. So we're going to build a generic component called Object Picker. And let's just go do that. Add item, Object Picker. So the magic of this starts with type param, at type param. Now this could be T, T1, T2, you could have multiples of them, but you're essentially saying that T item, anytime I'm using this type in here, is inferred, okay? And here's where it's inferred. I have parameters, which again are properties, right? So I have this list of selected items, which is a list of T item. This is a parameter, so I'm going to pass in my list of instruments. It's going to say, T item is now instrument. So anywhere we're using T item as a type, we know it's going to be an instrument. So I have the string property, item type, which we're going to set to instrument, and then plural, which will be instruments, right? So this is just for UI purposes. So we can say all instruments and selected instruments. The text property name of the instrument, which is what shows up in the list, we're going to use reflection for this. So that would be name. And the value property name, which would be ID. So we have our list of all items and our list of selected items that we start with. Okay? Now we've got a T item property, selected item, which is going to be instrument in our case. And then all of the code to pull out the value or the text is right there with a little bit of reflection. Item value of an item returns the get type, get property of the value, get value, toString. And the same with the text. Now remember I told you about this override on parameters set. This is a good example of when you would use that. You can't use onInitialize because you don't know what T item is. T item is a parameter that's passed in, right? So as soon as the code sets that all items are selected items, this is going to fire. So we'll know that all items is an instrument. We're not going to have anything hard coded in here. We're going to use T item, the ID, all of that. So the markup itself is just a table, right? Of course, it could be anything. You could be using, Bootstrap grids or whatever, but this one's just a table. And then you've got the buttons, the list on each side, the handlers, all that. It's pretty cool. Now, where the heck was I? Oh, yeah, here I am. All right, so now we're going to create MusicianEditor, which is going to have an instance of this in it. Pages, add, new item, MusicianEditor. All right, so this is going to have the same kind of thing as the instrument editor, except that after the name, we have our object picker instance. And now we have all items, selected items, right? These are all based on what we have in here. So we're passing in all instruments. We have a selected instruments somewhere. All right, edit, add, submit button pressed, all that. Got our JavaScript focus. All right, so now we're going to create a few musicians in that index file in the code behind, where we have this. We'll get rid of that and replace it. So now we're adding the instruments, but we're also adding musicians. Piano Patty, Shredding Shelly, Thumping Theo, and Banging Bob. Guess what instruments they play? All right, so now we'll add the rest of the code in the index code behind to support the musician UI. Right there. And this is, the same stuff that you've seen before. Delete musician button click, musician selected, edit musician, canceled, added, updated, all that stuff, all the goo. And the markup to edit musicians goes in the index file itself, right below the instrument editor. All right, so here's our musicians select. Here's our new button, edit button, delete button, and then our musician editor component. We have a reference to it. Everything should be good in the world. So, and the rest of this code just shows what that, the rest of this document just shows what the object picker is. It goes through all the code in there. All right, so we got our musicians here. Piano Patty. Let's edit Piano Patty. Piano Patty plays keyboards. Going to update. Shredding Shelly plays guitar. And of course, these all work as expected. There's a lot of enabling and disabling of buttons going on here. Thumpin' Theo plays bass. Bangin' Bob plays drums. All right, let's add a new instrument. Kazoo. And a new musician. Creepy Carl. Who plays kazoo. There you go. And so if I can edit these and you can see that they're associated accordingly. All right, so in the 3 minutes that are left, I'll take any questions you might have. Comments, concerns, yeah?
Can you tell us about the styling on the UI? What do you use to style? Is it just standard CSS?
Oh, yeah, check this out. Styling. Look at this. Bootstrap. That Bootstrap min CSS right there, just change it to your favorite Bootstrap CSS file and everything updates. Everything changes. Yeah, and that's what they use. In terms of using other CSS things like Sass and all that, I would urge you to check out the sessions at .NET Conf, focus on Blazor, because one of the guys there did a great session on all the CSS things that you can do with Blazor. Anyone else? Question? Yeah?
You've got JavaScript interop, and the JavaScript updates the DOM. Does the server know about that?
Does the server know about it?
And the server's got a model of the DOM in memory.
Yes.
Does the server know about your JavaScript?
Yeah. And that's there's a whole interop layer between JavaScript and Blazor just for that purpose. Yep. And it can go back the other way too. JavaScript can call .NET code. So, yeah. JavaScript is dead, long live JavaScript. Anyone else? Yeah.
In the TI example, can that use generic type constraints?
No. That's a good question. Can you generate type constraints? Like say, I only want, to allow iObservables or whatever. No, you can't. But what did Ryan say about that? I think he said that is something that they're working on because a lot of people want that feature. Yeah. Anyone else? You like it? It's good, right? It's good. All right, I'll see you later. Thanks.